So over the next 30 minutes, I'm going to share with you the battle tested patterns which you can use and practical strategies you can apply immediately if you are having any data infrastructure challenge or you are building an enterprise AI and ML application. So without further ado, let's dive in. Let's start with the problem. Training modern LLMs require petabyte of diverse data, text, images, audio, and video. But enterprise needs more than historical data. And when I said petabyte, it's not a typo. It's really a petabyte of diverse data. It needs a real-time stream, structured table, and unstructured documents all working together seamlessly. Whereas traditional data warehouses, which we have habitual of seeing around, can't handle this complexity. They are built for structured data and SQL queries. So everything has to be organized in a table. You know, they struggle with the variety and volume that AI LLM application require. I'm sure many of you have dealt with the typical PostgreSDB, which is basically a database, and also with the warehouses, and you have seen that it has to be organized. It can't accept the unstructured data. And if your data is logged in silos, which is very common for all the enterprises across department and systems, you can't build effective AI. The companies winning in AI today are not necessarily those with the best algorithm. They are the one with the superior data architecture. Traditional data warehouses are brilliant, when for their time. They were built for the worlds of rows and column, but today's data is totally different. It comes in the form of the PDF and video files and maybe, the sensor streams coming out from your IoT sensors. The warehouses, the data warehouses were not built to ingest this kind of diverse data. And most frustrating of all is data is probably trapped. Marketing has their own data. If you go to a typical mid-size enterprise, you see marketing has their own data, sales has their own data, engineering has their own data, and nobody can talk to each other. You can't build intelligent system on top of the fragmented foundations. So what does a modern system actually look like? Let me break down into 5 components that matters. Think of it like building a house. You need a solid foundation at every layer. At the bottom, or in the picture you can see from the top, it's a ingestion layer. Data has to get into your system somehow, right? Somehow that's sometime that's a historical record, Sometime it's streaming in real time from IoT devices, or it's coming right from your application logs. The key is being flexible enough to handle both kind of data, batch as well as the streaming. Then comes the storage. This is where things get interesting. So you want the infinite scalability of a data lake, but you also want the reliability guarantee that database has given us for decades. That's where the lakehouse architecture really proves its worth. So you get actually best of the both the worlds. Processing, we will talk about the storage layer in the next slide. Processing sits in the middle. So this is where the really real transformation, data transformation happens. Raw, messy data becomes clean, structured features that model can actually use, and you are running massive computation across hundreds of machines in parallel to make this data clean and ready to be consumed by LLM. And above that is the serving. Your model need fast access to data. So we are talking about millisecond response of time. Think about it. If you go to ChatGPT or Claude, you enter a query, you are not gonna wait for a minute or even bunch of seconds to wait for your response. You expect the response time in milliseconds. Feature stores vector database for semantic search. This layer is all about the speed and wrapping everything else. Governance. Who can access your data? How do you ensure privacy? How do you prove compliance? And this should not be an afterthought. It's very fundamental for enterprise to become successful. These five layers have to work in concert. Miss one and everything falls apart. Let's let me dive deeper into the storage layer because this represents a genuine breakthrough in the data architecture. This area is the one where most of the enterprise struggle because you want to store a large amount of data and you want to store at the economical price. And the data residency also matters. Where do you want to store? How long you want to store? So this becomes critical for a small company. For the longest time, you had to choose. Either you wanted cheap, flexible object storage that could hold anything, or you want a reliable transactional database that wouldn't corrupt your data. Pick one. But modern lake houses say, why choose? You can use object storage like S3, Azure Blob, or Google Cloud Storage, which gives you incredible economics without breaking your bank. We are talking about 90% cost reduction compared to traditional block storage. And when you are operating at scale, that's a different difference between a project that gets funded and one that doesn't. It might not be looking so exciting for now, but when you are working for an enterprise, when you are building something for an enterprise, how much is the expense is the really is the thing which actually moves the needle. But you layer technology on top of these blob storage, like Delta Lake, Iceberg, or Hoodie on top, and suddenly you got warehouse grade reliability. ACID transactions prevent data corruptions, and your queries are consistent. Your schema can evolve without breaking everything downstream. You can bring new columns, you can remove existing columns without modifying the already data or any other dependency, downstream dependency which you may have. Multi-tier storage is another key advantage. Frequently accessed data stays hot for performance, and older data automatically tiers down to warm and cold storage. The system manages this intelligently based on actual access pattern instead of changing the tiers of the storage manually, balancing performance and cost as your data ages. So at the end of the day, what I'm suggesting is keep the access data, which is frequent access data, in the hot storage. And the one which doesn't get access so frequently, keep it in the cold storage. It really make a difference in the expense you spend on the storage layer. And basically then you get the same access pattern, same query speed, but you get the best of the both the worlds. Now let's talk about what happens once data is stored. Processing is where the heavy lifting happens. So you have the data, you ingested the data from multiple sources, and it's raw, it's massive data, and turning it into something a model can consume, it's really which happens in the processing layer. And like I mentioned in the previous slide, we the modern AI and LLM see petabyte of data, which you cannot do that by the way on a single machine. So you need a cluster of machines. And that's where distributed computing comes in. There are open source framework, for example, Spark and Ray, which are available, which lets you spread this workload across hundreds or thousands of general purpose machine, which is very cheaper and can scale horizontally in thousands of machine without any issue. It's a tried and tested pattern, and many of the large enterprises uses hundreds and thousands of machine, general purpose machine, which scales horizontally. So now what used to take weeks can, when these machines put horizontally, they can be done, that work can be done in hours and the data can be cleaned. Moving to the next one, the feature engineering used to be earlier manual, very artisanal process. The data scientist would craft features by hand, but now we automate that pipeline. The system generates embeddings, creates derived features, and does the transformation all automatically. And on the serving side, speed is everything. When someone asks your AI a question, they're not going to wait. Vector databases enable semantic search, finding relevant documents by meaning. In earlier world, we have seen the regular search, which matches the exact key value which you enter into the search. But LLM don't rely on the exact match. They look for the semantic match. It means they try to find the word or the text which is similar in the meaning. This is where power, this RAG structure, vector databases, is something which powers all those impressive RAG application you have been hearing about. And feature store solves this really tricky problem, making sure the features your model was trained on match exactly what it sees in production. So there is no more training versus serving data skew. Now I know the governance and security doesn't sound very exciting, but let me tell you, this is what separates the organization that actually ship a enterprise level AI product from the one that get stuck in proof of concept forever. Access control is not about being restrictive. It's about being intentional. Different people need different data. Your finance team should not see your customer support ticket, and your customer support team should not see financial forecasting. You have to build that into your architecture from the start. And you cannot forget encryption. Encryption is pretty much everywhere. Data sitting in storage, it's encrypted. Data moving across network, it's encrypted. And this is not a paranoia, by the way. It's a basic hygiene I'm talking about. And modern encryption has negligible performance impact. So there is no excuse not to do it. Have your data encrypted. Privacy is a huge concern, especially with AI. And there are compliance and regulatory requirement with different countries across the world, which has a different requirement. You need system that can automatically detect personally identifiable information and handle it appropriately. Anonymize when you can, mask the data which you think could be PII, and delete when you must. You don't want to keep your data hanging around which you don't need. And make these decisions systematically, not ad hoc. Have a system which take care of it automatically. And when the auditor shows up, and of course they will, like I was saying, for example, Europe has very tight compliance on what kind of data you capture from your consumer, where do you store it, how do you mask it, and what application you feed this data with. So auditors do come and then audit your data strategies. And you need to show them when they show at your door, you need to show them complete lineage of your data. Where did this data come from? Who touched it? What transformations happened? And that audit trail is not optional for regulated industries. So training large model is genuinely different from traditional machine learning. The scale, the diversity, the infrastructure requirement, everything changes. You are talking about training data measured in terms of trillions of tokens. I'm not talking millions, I'm not talking billions, it's trillions of tokens. And it can't just be scrapped from web pages. How many web pages you are going to scrap? You need high quality documents, code repository, conversational data, and domain specific content. And diversity of this data matters as much as volume. Your LLM would like to see not only just the text, but the audio, video, and pictures of the data because most of the LLM model are multi-model nowadays. Because the user wants to throw at you everything, picture, video, text, audio, whatever it wants to, which makes its life easy. It wants to throw at your LLM model. And here is something that uh, bites people: reproducibility. You spend $3 million training a model. 6 months later, you need to reproduce that run for an audit or to understand a behavior. Can you do that? Do you know exactly what data went into that when you run the training? Version control for database can solve this problem, and it's not an optional for enterprise AI. And GPU utilization, those machines cost thousands of dollars per hour. And if your data pipeline can't keep them fed, they are sitting idle waiting for the data. So you're literally burning money. 95% or 90 to 95% utilization should be your target for your compute machines. I'm going to be blunt about something here. Quality beats quantity every single time. Here is a story that unfortunately too common. Company spends $3 million on compute to train a large language model. They collected massive amount of data, more data than any competitor they have, and they take pride in that because they have that kind of data. They thought scale would solve everything. They have the data, they have the money, they can come in, feed this data to this LLM model, and voila, it will train automatically and everything will fall in place. The model launches, but it's terrible. It repeats itself. It generates toxic output. It fails basic tasks. Why? Because nobody invested in data quality. They had duplicates everywhere. Toxic content made it through. Low quality source polluted the training set. And they threw the whole thing away and started over. 3 million gone, just wiped out. Deduplication of the data is not a glamorous work, but it's essential. Models that sees the same example 1,000 times memorize instead of learning, and you are wasting compute on redundant information. Content filtering protects you from the obvious stuff: toxic language, extreme bias, and completely wrong information. Your model learns from every example. I would give the simple example saying that feed your LLM model a garbage and you'll get the garbage back. And standardization means the data from a different 100 different sources flow through the same pipeline consistently. Format standards, validation rule, quality checks, build all this into your pipeline, not as a manual step afterwards. Invest in data quality from day one. It is the highest ROI work in your entire AI pipeline. Let me talk about a question that I get constantly. Should we build for real time or batch processing? Because I don't want to wait a long time before the batch can process and the output or prediction is available versus I want to do it at the real time, which is very expensive. Some things genuinely, what I believe is some things uh, genuinely need real time processing. For example, fraud detection pipeline, if you have, can't wait until tomorrow's batch job runs. Anybody does a credit card transaction trying to make a fraud, it has to be stopped immediately. Product recommendation feel broken if they are based on yesterday's behavior. So when millisecond matters, streaming architectures are your friend. But plenty of things work better as a bad job. Training models, generating reports, complex historical analysis, these are batch workloads. They don't need to happen in real time. And forcing them into a stream architecture just make everything complex and very expensive. The mistake is forcing everything into one paradigm. Have a clear cut idea of what has to be real time and what can be done through batch. Because real time only architecture are expensive and complicated, but batch only architectures feel slow and outdated. So you need to support both and have the flexibility built into your data architecture. Let me get concrete for a moment and share a stack that actually works in production at scale. So I talked about all these fields, but you would imagine, how do I implement it? How do I implement ingestion, storage, processing, orchestration, serving, which you talked about? I'm not going to go into much details, but I'm going to give you some open source framework which makes these stages possible. So go out and read more about these open source platforms. These are huge, and thousands of people have contributed to this open source code to bring it to the place where it is as of today. Let's start with the ingestion layer. You have got Kafka handling for streaming data, Debezium for capturing database changes in real time. Everything and anytime any row get updated in your database, you'll get notified immediately. So that immediately flows into your data lake. Fivetran handle all those SaaS connector. You want to bring diverse sort of data sources, and you need connectors for that. Fivetran can handle all those SaaS connector. Salesforce, Marketo, whatever the clouds app you are using, Fivetran makes it easier to ingest the data from. Storage is S3 with Delta Lake or Iceberg on top. S3 gives you infinite scale at low cost, and the data Delta Lake gives you the transactional guarantee you need to trust that data. Spark does the heavy processing. Spark and Ray does the heavy processing. DBT handles SQL transformation with version control and testing. These tools have become industry standard because they work. You go to any company and ask what do they use for data processing. Most of the time, the answer you would get is Apache Spark. And if it's a heavily stream processing framework, then you will hear the another name, Apache Flink. But these are pretty same to use it. And Airflow orchestrate everything. You know, when I say everything, it means everything. It's your scheduler, it's your dependency manager, and it's your workflow engine. And for serving, Fast API gives you lightweight Python-based API. Trino lets you query everything with SQL. Pinecone handle vector search for RAG application. That's your vector database, where all the embedding and vectors will go into this database. And the last but not the least one is the monitoring. So you need to use Prometheus plus Grafana that gives you visibility into what's actually happening. In an enterprise application, if you don't have the monitoring set up right, you don't know what your application is doing. So you have the blind spot and you can't improve anything which you can't measure. So this example which I gave you is not the only possible stack, but it's proven at scale across hundreds of companies. So I would highly suggest take a picture of this slide if you haven't, and look for the open source software which I talked about, and go to the Google and search and read more about it. So these are very powerful open source software which does the each stage very beautifully. And you don't have to provide you if you are doing a POC, you don't have to spend any dime on it. RAG architecture integration. Retrieval augmented generation has become incredibly important. Let me walk you through how the data infrastructure enables it. It starts with getting documents into your system. So you have all different kind of data. You are parsing PDF, HTML, Markdown, whatever format your knowledge lives in. But you can't just dump the raw text into a vector database. So that's a mistake, common mistake people see, people make. They say, okay, I have the data, I set up the access, I ingested the data, now I'm gonna throw everything what I have at LLM. At LLM, it smartly learn everything and just give me the right context, right information what I need. But that's not true. You have to ensure the data structure which you are feeding to your LLM, that is right data, header, structure of the data, section, table, everything carries meaning. And the next step is the chunking. How do you chunk the data? Chunk too small, you lose context. Chunk too large and retrieval become imprecise. Semantic chunking tries to keep related concepts together. It's very hard than it sounds. Then you generate embeddings for those chunks. These are dense vector representation of a meaning. I'm not sure how many people in the room knows about these terminology. For example, semantic search, chunking, and embedded generation. So if you don't know, just I would suggest go to the Google and read more about it. This is very interesting. So think about it. Embedded generation is from a term, it generates a vector of uh, numerical representation of that text. So these are the embeddings are the dense vector representation of a meaning. Similar concept end up close together in this high dimensional space. Think about, let's say you have a graph and then there are different points in those graphs. If it's a similar meaning, for example, king or queen, they will be close to each other in that vector space. You can use OpenAI's embeddings, which is open source, and to train your own. And there are different open source are available. Each has its own trade-off. OpenAI versus Cohere. So you can try and you can read more about it. Those embeddings get indexed in a specialized vector database. These databases are optimized for similarity search, not for the exact search which we have been seeing in earlier time with the traditional databases. And what is similarity search? Like I gave you an example, if you are searching for a queen, king also would appear in the list because it's similar in the meaning in that context. Finding the most relevant document in millisecond across billions of vectors. But here is a trick. Don't rely on vector search alone. Users are human, they want to do the hybrid search. Not only they are looking for a semantic search with, but they are also looking the exact search with the good old keyword matching. Sometimes you want document that contains specific terms, regardless of the semantic meaning. So hybrid is the way to go. And re-ranking gives you a second pass. Your initial search might return 50 candidates. A re-ranking model looks at all 50, identifies the truly most relevant, let's say 5 out of that to pass to your LLM model. Get this pipeline right and RAG becomes incredibly powerful. Let's talk about money because data infrastructure can get very expensive if you are not careful. I worked at a company where they spend $2 million a year on storage, and we did an architecture review and we found out that we are spending this money on expensive block storage, whereas object storage would have worked fine and the data was not compressed. They were keeping everything in host storage even though it was rarely accessed. So we migrated them to object storage, implemented Parquet format with compression, set up intelligent tiering, and imagine what the annual cost would have come down to. $300,000, from 2 million to $300,000. Same amount of data, same query performance, and 80 to 85% of the cost reduction. Compute is your big expense. Auto scaling is critical, but you don't want to pay for idle machine. You can use spot instance for batch workload where you can save 60 to 70% of the money. Yes, they get interrupted, but that's fine for the non-critical batch jobs. And here is a hard truth. Retrofitting scalability into your existing system costs more than what you would spend while building it right from the start. Horizontal scaling is your friend. Don't build system that can only scale vertically. You don't want to buy you don't want to buy the bigger machine. They are super expensive. You want to build out the system which scales out with the general purpose machine by adding more machines, which is cheaper. And partitioning is massively underrated. If you organize your data intelligently by date, by geography, by customer segment, your query can skip 95% of your data. Bad partitioning means every query scans everything, which is not good. And caching deserves its own discussion. So if you are hitting your database for the same data over and over, cache it. And compressing seems counterintuitive, but it actually makes things faster because whatever you are sending over the network, now you are sending the few bytes because it's compressed. And the modern compression models are incredibly fast in doing the coding and decoding. MLOps, all about treating models like professional software artifact. Experiment tracking matters because you might run hundreds of thousands of training experiment. Which hyperparameter worked, which dataset version performed best. Tools like MLflow and weights and biases capture everything you can reproduce and improve. Model registries gives you version control for model, like similar thing for the Docker registry, which gives you for the Docker images. And CI/CD for machine learning means automated testing before deployment. Does this model perform better than the current production model? Does it meet latency requirement? Are there any failure in the test set? Automate these check. And feature store solves a subtle but critical problem. The feature you use during training need to match exactly what the model sees in production. Feature store guarantee this consistency. And monitoring, we talked about, it catches problem in production. So the data in summary, I would say the data lake is the foundation and MLOps is the operational discipline that runs on top of it. So here is the migration strategy. If you are migrating from legacy system to a modern data lake, here is the playbook that works. Phase one is assessment. Don't skip this. Inventory everything. Whatever the data you have, write it down. Understand your current state deeply. Define where you want to go. Phase two is pilot. Pick something non-critical. Prove the architecture work and learn what you don't know. Build confidence in your team and your stakeholder. And phase three is moving high value use case. Find something that matters to the business. Migrate it and show result. Quick wins generally build momentum and justify continued investment. And phase four is dual running, where you keep your legacy system running while the new system prove itself. This is expensive, I understand, because you are running both the system, legacy and the new one, but it de-risks your migration. You can validate everything before cutting over. And phase five is finally decommission the legacy infrastructure. Turn it off. Once you validate the new infrastructure works fine, redirect those savings to innovation. For a large enterprise, I would say these steps would take anywhere between 12 to 18 months. It's a marathon. Think about it. It's not a sprint. So plan accordingly. So what do you actually do when you get back to your work? I just want to leave you with some of the action plan. Start by mapping what you have like inventory, where what are all your data sources, which use case matter most to your business, Don't try to tackle everything at once. Find the highest value problem and focus there. Choose your technology stack based on what your team can actually operate on. You want to work with something which you are comfortable with. The fanciest tool in the world doesn't help if nobody on your team knows how to use it. Match technology to your capability and launch a focused pilot. One domain, one use case, real business value, not a toy problem. Prove this before you scale. Establish, I talked about governance. Establish that first. It's not a fancy, it's not exciting, but it's much easier to have it set up before your petabyte of data and dozens of team comes into play. Set the policies now while it is still manageable and build cross-functional team, data engineer, ML engineer, platform engineers. They need to all work together constantly. Break down organizational silos and define clear metric for success. How your success would look like. How will you know when this is working? What are the adoption rate you are targeting? Time to insight. What is the business impact? Make success measurable and visible. And start small, prove value, and then scale deliberately. Let me leave you with this six things to remember from today. First, lakehouse architectures give you the flexibility of the data lake with the reliability of the warehouses. You don't have to choose one anymore. Second, data quality is your highest ROI investment. LLM model is nothing without clean data. Every dollar spent on quality saves $10 on fixing problems later. And third, design for scale from the beginning, but implement based on the actual need. Don't over engineer it. Don't under engineer it. Build what you need and when you need it. And fourth, automate relentlessly. This is my favorite. Manual processes don't scale. And many companies who are starting off, they get into this paranoia to ship the things out and they compromise on automation. Don't do that. Automate relentlessly. Take an extra time and automate everything. Trust me, it's gonna save lots of headaches and lots of cycle going forward. Because the manual processes, they don't not only just they scale, they introduce errors. Build automation into your system from day one. Take benefit of the CI/CD pipeline end to end. And fifth, culture matters as much as technology. The best architecture in the world fails with poor organizational culture. Faster data-driven decision making across your company is only enabled with the right culture. And six is think long term, build for tomorrow. The architectural decision which you take today determine what's possible tomorrow. Build foundations that will serve you for years to come and which are scalable with the tomorrow's data. These patterns which I have discussed with you, they are proven at scale. It's just about execution now. So that's what I wanted to share with you today. Thank you for your attention. I'm happy to take any question you have, and please connect me on the LinkedIn if you want to continue this conversation. Thank you.
Awesome. Thank you so, so much. Please, a round of applause for Mr. Anat for this amazing, amazing presentation. Thank you so much. I got quite a bit, but I just wanted to buttress on the fact that in order to scale in the enterprise level, you have to start from small and you also have to recognize the value first before actually moving. Before we move into the question and answer session, I think we have two categories of people in this room today. The first category are those that understand clearly everything you're saying and are ready to put this into use at their office. And the second category of people, I don't know, I think I may fall under. And some of the part of the presentation was being translated as though it was Chinese because we really didn't get all the lingo. But that's why we are here to learn and to become better. Awesome. So right now we are going to open the floor. We have 10 minutes for question and answer. So if you do have questions, please put it in the chat and I would communicate that to Mr. Anat. So if you have questions, please put it in the chat box.
Yeah, I just want to call out that don't be scared with these terminology, some of the terminology and terms if you are new to AI LLM model. The people who have done at least some work of AI LLM model, I'm sure they are familiar with these terminology. But if you are not, don't be scared. Start learning more, learning about it. If you have the professional, if you have the software background, these terms are or these technologies are easier to learn and easier to adapt as long as you have the basic understanding of the software. So don't be scared with this. Go out, take your time and learn bit by bit.
Awesome. I agree with you. Do you have any questions? I'm currently looking at the chat. If you do have questions, I will be more than happy to take them at this point. Sure.
Hello, everyone. Yeah, thank you so much for the wonderful presentation. Very insightful. Yeah, so my question is from some of the things that we've heard or seen at work or playing out in terms of AI models and security and things around that. So one of my the perspectives and things that I've heard is that it's not even so much about maybe the AI models or the LLM, but the data. That's where we need to focus on. So when you were making your presentation, there's something that when you said about governance and security framework, you mentioned about some of the key concepts that can help with data security, access control, encryption, and things around that. So I'm trying to ask like, is there any built-in solution or maybe from your experience, how this problem can be solved? Because if somebody creates a model, but how you use the model, how you use the data is the important thing, like data bias and things around that. Like, it's not even the person that created the model, how you use it. If anything goes wrong, who's going to be responsible? Is it the owner of the model or the person that used the data wrongly? There are areas like that that are still not so clear. So is there any built-in solution in terms of governance that is in the solution that you present, or maybe your perspective? Thank you.
Yeah. No, thank you. Thank you for the question. It's an excellent question. So the governance is multi-layer. So you, like I was talking about, you have to establish the contract, like who access the data. And to do that, there are some technologies available. For example, RBAC, which is role-based access of data, which is common, very common for providing this kind of granularity, who can access what kind of data. And if you are using, let's say, Kubernetes provide RBAC right out of the box. So you can use RBAC, you can decide the role, who different principals have different access level of the data. So that's your RBAC. Of course, you have to authenticate the user before they can log in and even start doing anything. So authenticate, authorize, and then about the toxicity and the other the bias things, it's very hard. I think the RBAC access and authentication is very easy to set up. It's a proven pattern, proven strategy. If you are working out of cloud, it's right there off the shelf. But building something which take control of the biases, toxic content, filtering those out, it's this there is not a solution available in the cloud which you can use right off the box. Because for you as an enterprise, you have to decide what toxicity means for you, right? What is the bias for you? Your business would be different, which basically you have to first formulate and define what a bias for you as a business, okay? And what a toxicity mean, what level of toxicity you can tolerate and what you cannot. Uh, so you have to build all those three through the RAG. So RAG is a very powerful mechanism which you can have a setup. I think there is one slide I went through the RAG. So you can build a RAG and which can filter all these content and take in the user queries, what user is talking about, and don't directly feed it to your training data, because most of the modern LLM system uh, also learn when they serve. And there have been in the early days of the LLM model, it happened is the people got rogue, and they started sending the wrong queries, wrong LLM queries, so that the model can learn all those wrong things, and then at the end of the day they can break this LLM model. So now the enterprise have learned it hard way. They put the RAG and the filtering in the ingestion level before they make the user query as a training data for the LLM model. So they remove the toxicity, they remove the all the bad stuff, they remove all the biases, and they remove the competitor questions as well. Things, because user is very very innovative in the terms like how do they prompt their query. For example, it happened that in one company they tried to make the LLM model learn that your competitor is better than you. Okay, and there are multiple ways to say it when you query your LLM model. So that's doesn't come under toxicity, that doesn't come under any swear word, that doesn't come under any biases, but it's just that they are training your model saying that your competitor is better than you. And you don't want this to happen to your LLM model, that your model start suggesting go to my competitor, not to me. So all those things you learn and you build layer by layer through this RAG and filtering approach, all those technologies put together, and that's how your LLM model matures. So unfortunately for the uh, governance part, some part is easier, some part is hard. Make sense?
Thank
Does
you.
it answer your question?
Thank you. Thank you so much. We have another question here. I'm just going to read it out. It's also still for you, Mr. Anat. How does Kubernetes enhance the deployment, scaling, and management of big data workloads across distributed systems? That's the first one. I think you can answer that, and then I'll
Yes,
take
yes.
ask the
I
second.
think it's a great question. The Kubernetes is right now the default mechanism to deploy, to train, or to serve your models. Uh, and luckily there are many open source software available in the Kubernetes which you can use. I talked about Spark and Ray, so they are open source framework which you can use for compute, for doing ETL, to cleaning their data, to run your massive batch job. Spark would do it beautifully, and it will scatter your job across hundreds and thousands of general purpose machine, instead of asking you to buy one bigger machine and run all your ETL pipeline onto that. It won't. So it will just take hundreds of thousands of general purpose machine, which comes very cheap. Take any AWS, be it AWS, GCP, any cloud provider. These general purpose machines are cheaper, and Spark, which lets you run your ETL pipeline on hundreds of thousands of these general purpose machine and do the data transformation. So that's for the compute. And for serving, there are K-serve available. There is a something called as Kubeflow. If you go to the internet, something Kubeflow is a platform for doing the AI and ML ops on the Kubernetes. And when I say it's not a framework, it's a platform, it means it is a combination of different frameworks. So it's available. So the solution is available for serving, for training, for hyperparameter tuning, as well as it gives you nice UI and dashboard for doing the version control. So look at the Kubeflow, and you can also look at the ML flow as well for doing all your AI ML operation stages. So whatever stage you pick, there is a solution for that.
Awesome. Awesome. Thank you so much. So the next question, which would be the last one for this session, is what infrastructure challenges arise when hosting LLMs on Kubernetes clusters, and how can big data storage and GPU orchestration be optimized to support them?
Yes. So the challenges are that for serving, it needs the response in the millisecond. So you want the data to be trained and response has to come in the millisecond. You can use the GPU. There are GPUs available, and you can choose these GPUs for different kind of workload. For serving, you definitely want the good quality GPUs so that you can respond it in the millisecond format, millisecond time frame. And Kubernetes has all these infrastructure and framework uh, built in that you can pick different GPU or CPU for different kind of workload. You can say that I want this GPU for running my inference pipeline, versus you can say I want this GPU for running my training pipeline, which basically takes longer time and crunch larger amount of data and very expensive as well. So you can pick uh, different executors for crunching different workload.
Awesome. So just the very, very last one. How does Kubernetes help run and scale large language models that use big data?
Yes, scaling is easier with the Kubernetes. I think this is a proven tested model. You can scale horizontally. So every time you come in, don't scale it vertically, scale it always scale it vertically. And there is something called as autoscaler in Kubernetes, which you can use to scale your pod. When you use the autoscaler works in terms of a queue, right? So they look at your memory and CPU and maybe the storage consumption, and based on that they look if your memory or CPU consumption is going up, they launch a new pod to share that load, so it scales automatically. And now there is a lot of innovation has come into the autoscaler. There is something called as Carpenter. So look at the internet. It's an open source again. Carpenter, which will give you more flexibility in how do you want to scale your pipeline, how do you want to scale application. For example, most of the autoscaler used to work like when the load comes in, then they scale. But in Carpenter, you can set up policies such that you can pre-scale your application. Let's say if the Thanksgiving is coming and if you are e-commerce application, you on those days you expect your application to be scaled to maximum. Basically, you don't want to have the customer have the experience of your application is down. So you can pre-scale your application for those days, or when you are basically know when the batch of data comes in to process, to train, or to inference. You can do all those kind of beautiful techniques. Basically, you have the finer control on your auto scaling.
Awesome. Awesome. Thank you so, so much. I think for anything, this just encourages me to go back to all my AI certifications I've been pushing, and all the tabs are left open on my computer. Thank you so, so much, Mr. Anat. Thank you so much. You have a question? Okay, we just have 1 minute. You can go ahead.
Yes, sir. Good morning. Please, I want to know the difference between data government and AI governments.
Mr. Anat, were you able to get the question? Okay.
Yeah, excuse me. So the question is, what is the difference between data governance and AI governance, right?
Yes.
Okay. So uh, AI is as good as your data. Okay. So the quality of the data you train on and what you can train, what you cannot train, is define how your AI behaves. So now the countries has compliance requirement where they ask you to disclose what kind of data you have trained your AI LLM model on, how long the data was residing, and who has the access, where did you source this data from. So you have to disclose all that. So essentially the data governance will be your AI governance. Where did this data come from? How long you have been storing this data? What all kind of data your LLM model is trained on? Is it a pirated data? Is it some data where people have their uh, proprietary data? They want to know all. So when they say AI governance, at the end of the day, they are looking at what kind of data you brought in to train your LLM model. So under the hood, AI governance is nothing but the data governance. Does that answer your question?
Awesome. Awesome. Thank you. So without wasting any much time, thank you for all the questions, and thank you so much again, Mr. Anat. You've been amazing this morning. Please, let's a round of applause for me. A round of applause.
Thank you.
Okay.